and we are just about to start the session. So we haven't started the session so far. Before we start the session, let me quickly introduce myself. Okay. So my name is Raghu Raman. You can just call me Raghu. I work as an instructor with Intellipaat, and I have around 16 years of industry experience. In that, almost 10 years goes into big data management. So I started working on big data from 2010 onwards. So I can safely say that for the past almost 10 years, I have been working on various tools and technologies related to big data. So I also work with Intellipaat as one of the instructor. And today, as you could have probably seen, our agenda is to discuss big data and Apache Spark, right? So I welcome all of you to our discussion on big data and Apache Spark. And since this is going to be a webinar, an online webinar, the way I normally handle the session is like, see, I will be talking about big data, talking about Spark, and I will be also doing a demonstration on Spark. And this will take around 1 hour, roughly around 1 hour, let's say, right? And then I will give you enough time to ask your questions. So we will definitely discuss your questions, that is for sure. But, since it is like a topic, what I would like to do is I will first conduct the session, and that will be more or less about an hour. And once we are done with the session, I will be more than happy to pick up your questions, any questions you have related to the topic, right? So with that in mind, let's start our discussion. So I will be using slides a little bit, and sometimes I will be also using the code examples. Let's start the session with, a basic set of slides. So the first thing that we are going to discuss is what exactly is big data. See, big data is a very hot term in the market, right? So if you are looking for new projects or if you're looking for new jobs, you see this term called big data everywhere. A lot of companies are looking for professionals who are qualified in big data. But what exactly is big data? So the first thing, even before talking about big data, the first thing you need to understand is what is data. So normally when we come to analytics, we classify the data in 3 separate categories. There is something called structured data, then you have semi-structured data, and then you have unstructured data. Now, I'm not talking about big data, I'm talking about regular data, right? So the first category is what we call structured data. You see, any data which is in the row column format is what we call structured data. An example will be a CSV file or an Excel workbook, or if you're familiar with this term, databases, an RDBMS table. All this can be called structured data. Now, why do you call them structured data? Because they have a format, right? They have a row and they have a column. The structure is very well defined. That is why we call them structured data. And when it comes to analyzing structured data, we already have a lot of ways to do this. Like I said, even a simple Excel workbook can do this, or you can go to databases, or you can go to data warehouses. All this will be able to help you analyze structured data. Or in my own terms, I sometimes say that structured data is what we call traditional data, the data that you and me already know. The second type of data is what you call semi-structured data. So this is the type of data which has some structure, but not like in the row column format. A classic example will be something called XML files. So if you look at something called XML files, you will see that these XML files will have a certain, pattern, right? They have something called root tag and row tag and all, but they don't have row column format. Another example will be something called JSON, JavaScript object notation. So JSON files are key value pairs usually. So they again represent some structure, but not like in a row column format. And the third type of data is what you call unstructured data. So unstructured data is this type of data where you do not have any kind of structure. For example, audio files, video files, images, binary files, all these are examples of unstructured data. So when we say data analysis, the first question will be, what kind of data are you going to analyze, right? And we will come to that. And now let's discuss what exactly is big data. So big data is a collection of extremely large data sets that may be analyzed computationally to reveal patterns, trends, associations, especially relating to human behavior. Now, from the term itself, when you say big data, the first thing you need to understand is the size of the data. So big data represents data sets which are really huge. When I say really huge, they can be in the order of terabytes and petabytes and even much more, right? So the first thing that you need to understand is that when somebody says big data, they refer to data which is like really huge. Like I said, probably in the order of terabytes and even bigger. The second speciality of big data is, it's not only big, it's also complex. So you may be wondering, okay, I understand big data means huge amount of data, but can you give me some real life example? Yes, some of the examples that I can share with you. One is black box data. So if you look at a flight, okay, every flight has this black box, right? So what happens when a flight is, let's say there is a flight which is flying from London to, say, New York, and let's assume it takes 10 hours. So during this 10 hours of flight, there are a lot of sensors on board on the flight, and they capture a lot of data. And do you know what? During a single flight of about 10 hours, the sensors collect around 1.5 terabyte of data. So imagine if you are looking at an airlines, probably something like, I don't know, Emirates or Lufthansa. Imagine how many flights they are having every day, right? So each flight, imagine it collects 1.5 terabyte of data. So end of the day, you are talking about probably 5,000 or 10,000 terabyte of data. Now, where do you store this? First problem. And how do you analyze it? Second problem. Another example for big data is this social media data. So if you look at social media, say for example, Facebook or Instagram, any social media platform, by collecting the social media data, you can understand trends and patterns. To give you a simple example, right now, the US elections are over, right? And one of the deciding factor in US elections is social media. So even before the actual elections, the presidential candidates, right, Joe Biden and Donald Trump, they were able to collect the public opinion about themselves. How do they do this? They collect all the public tweets and Facebook posts and comments and all. Now this account for terabytes and terabytes of data. If you look at only Twitter data, and let's suppose you're collecting Twitter data, tweets related to somebody like Trump, uh, every day millions of tweets are being shared, right? And if you download all this Twitter data and try to analyze like what people are talking about Trump, that will be in the size of terabytes. So how do you analyze this? Another example, right? Then you have lots and lots of other examples. For example, power grid data, transport data, stock exchange data, search engine data. All these platforms generate huge amount of data. Okay, so big data means huge amount of data. What's the problem here? See, size is one of the problems, but we were already having this problem before. Now, if size is only your problem, then you don't have to worry. For example, you can actually use data warehousing techniques to store huge amount of data and analyze them if you want. But size is not the only factor related to big data. So let's explore them. So normally when we say big data, there are like 5 V's of big data. So there are 5 properties of big data. You can see that they are listed here. So they are like volume, variety, veracity, value, and velocity. So these are called the 5 V's of big data, or these are the properties of big data. So what is volume? We already know what is volume, right? Volume means the size of the data. So definitely, if you would like to call something as big data, there should be huge volume of data. We already know this. Second property of big data is called variety. Variety means different types of data. I mean, think about it. Imagine you would like to analyze social media data to understand whether the US population is supporting Donald Trump or against Donald Trump. So when you want to do this, right, you may be collecting tweets, you may be collecting images, you may be collecting videos, all type of data. That is variety. So how do you analyze all this data? If I had only proper structured data, then I'm happy. But what if I tell you that you have terabytes of data, but that also contains images and videos and whatnot? How do you analyze them? So that is the variety problem. Third is veracity. Veracity talks about the quality of the data. Like I said, when you are collecting huge amount of data, how do you ensure that the data you are collecting is having quality? That's called veracity. And there is something called value, which is not that important. The last one is velocity. Velocity deals with the speed of the data. And I think velocity is a very important point. For example, what is an example of velocity? Let's assume you are working for a bank, okay? And let's assume you are working for one of the biggest banks, any bank, probably Citibank or any huge bank that you know. Now, you would like to design an application which will catch credit card fraud. All of you know that there is something called credit card fraud, right? So people may steal your credit card number, They may steal your identity, and a lot of fraud happens. Now, you want to design a system which will catch this credit card fraud. What is your problem? The problem is every minute, millions of people will be using credit cards. And you need to analyze all these millions of transactions every minute, apply some logic, decide whether it is fraud or not. So your challenge is not really the analysis. I mean, the analysis can be simple, but your challenge is velocity. Every minute you need to analyze, let's say 1 million credit card transactions. How do you do this? So that is again a problem with big data, or a characteristic of big data. So we normally say that if you have these 5 V's, then that is what represents big data. And now let's talk about what is Hadoop. And by the way, today's class is more or less to give you a feel of how we conduct the class at Intellipaat. We are not having an actual class. I hope most of you understand this. I mean, in reality, if I have to talk about big data, I can talk much more. But since this is a webinar and we have limited time, I will be restricting myself to only the important topics. Okay, so what exactly is Hadoop? So Apache Hadoop is a platform used for storing big data across a spectrum of devices. So the first thing you need to understand is this term called big data started becoming popular somewhere around 2005. Okay. And at that point in time, there was no solution to handle big data. People were all talking about big data, but in reality, there was no solution. Hadoop was the first solution we got for big data. So Apache Hadoop is a platform which will help you to store and analyze big data. And it is called Apache Hadoop because it is open source. So Hadoop is an open source solution, meaning the source code is freely available. You can download Hadoop for free, install it for free. It is open source. And Hadoop uses something called parallel processing to analyze huge amount of data and then produce results, right? And Hadoop comes with a storage layer called HDFS and a computational layer called MapReduce. So to put it very simply, maybe some of you may be wondering how Hadoop is able to solve this problem, right? So Hadoop is able to solve this problem in a very nice way. Okay, so what Hadoop does is very simple. Hadoop, first of all, gets installed in a group of machines. So probably what I will do, I will take my pen if you allow me. I will just talk about this for a minute. Now, let me take my pen and let me go here. Thank you. And let me draw this. So imagine you have, let's say, 3 machines. So I have, let's say, 3 machines, okay? And each machine, let's assume each machine has, say, 5 terabyte of hard disk. So I'm going to write it here, 5 terabyte hard disk. Again, this machine also has 5 terabyte hard disk. This machine also has 5 terabyte hard disk. And these machines are also having CPU and RAM. So maybe this guy has 2 CPU and 16 GB RAM. Even this machine has 2 CPU and 16 GB RAM. Even this machine has 2 CPU and 16 GB RAM. So let's assume you have 3 machines like this, okay? Each machine has 5 terabyte hard disk, 2 CPU, and 16 GB RAM. So when you install Hadoop, what happens is Hadoop gets installed in all these machines. Okay, and once Hadoop gets installed in all these 3 machines, it will be able to use a total space of 15 GB, sorry, 15 PB together. So basically what happens, since each machine is having 5 terabyte hard disk, Hadoop can combine these storage together and project as a single 15 terabyte storage. So this is what you call a Hadoop cluster. A Hadoop cluster is basically a group of machines. Now, in this example, I told you only about 3 machines, but there are Hadoop clusters with 300 machines and 1,000 machines. So imagine you have 1,000 machines in a Hadoop cluster, and each machine has 5 terabyte of hard disk. You are talking about 5,000 terabyte of storage. So Hadoop can leverage the individual storage of machines, combine them, and project as a single storage. So in big data, one of the challenge is how do you store huge amount of data? And Hadoop solve it just like this. So with Hadoop, you will be able to store any size of data. The second thing is, when the data gets stored and when it comes to processing the data, Hadoop can leverage the CPU and RAM of all the machines in the cluster. So it does something we call parallel processing. So rather than one machine processing the whole data, say hundreds of machines will be doing parallel processing. So this is how Hadoop solves your big data problem. Okay, and like I said, Hadoop is one of the earliest solutions when it talks about big data, right? And this is just a slide which talks about the history of Hadoop. Nothing great here. Hadoop was created in 2006. Then in 2011, a lot of other sub-project came. In 2017, we got Hadoop version 3, etc., etc., right? Okay, and our discussion is also about somebody called Apache Spark. So let me type it here. So in today's discussion, we are going to discuss about Hadoop and also about something called Apache Spark. So what is Apache Spark? So Apache Spark is, again, a distributed processing engine for big data. The purpose of Spark is to process huge amount of data parallelly. And why are we talking about Hadoop and Spark together? It is because Spark can be installed on top of Hadoop. So if you already have, let's say, a Hadoop cluster, right? You can install Spark on top of the Hadoop cluster, and then Hadoop can store all your data, and Spark will be able to process all your data. So Apache Spark is the latest processing engine in the big data world. I know that you have a lot of questions right now, and like I said, I will give you enough time to ask questions. Don't worry, right? So, so this is the official website of Apache Spark. It is spark.apache.org. And if you look at here, it's clearly written, Apache Spark is a unified analytics engine for large-scale data processing. And some of the specialities of Spark, you can find it here. First of all, the speed. Run workloads 100 times faster. Now you may be wondering, when you say 100 times faster, faster than what? Yeah, so you are saying that Spark is running the workloads 100 times faster. Fine. 100 times faster than what? Faster than MapReduce. So there is another execution engine which we call MapReduce. MapReduce is a very old big data processing engine. This is actually the default processing engine on Hadoop. So if you're downloading and installing Hadoop, by default, you will be getting a processing engine called MapReduce. And MapReduce was really popular at one point in time, but in the modern day, nobody is using MapReduce. That is because we have Spark. So Spark can process your data 100 times faster than MapReduce. So I still remember, because I started working with Hadoop from 2010 almost, right? So in 2010, when we were working on Hadoop, we had only MapReduce. This was like 10 years before, right? So at that point in time, the only way to analyze the data was using MapReduce. But in the modern day, we have got Spark. So Spark is 100 times faster than MapReduce. Second advantage is ease of use. Write applications quickly in Java, Scala, Python, R, and SQL. So when you are using Spark, you can program in Spark using any of these languages. So you can use Java, you can use Scala, you can use Python, R, and SQL. So these are the supported languages on Spark. And many people usually ask me, hey, why there are many languages and which language should I choose? So the answer is very simple. See, Java is preferred in case if, let's say, you are working for a company and most of the developers are having Java background, then if you want to implement a solution in Spark, then writing Spark programs in Java makes sense because you already know Java and you can do that. Scala is the language in which Spark is written. So the source code of Apache Spark is written in a language called Scala. And accordingly, a lot of people prefer Apache Spark with Scala. Even I do the same. So I am a Spark developer, and I primarily use Scala as my programming language. What about Python? So Python is very popular in the machine learning area, right? I hope you are aware of the latest trends in the market. Machine learning is one of the hottest topics in the market right now. Now, if you are a person coming from the machine learning background, then probably you are more comfortable with Python. And one of the specialities of Spark is that using Spark, you can do machine learning on big data, which is very popular. So let's say you are a machine learning person, you know a lot of Python, and you want to implement machine learning on huge amount of data, then go for Python. And R is for those people who are coming in the data science background, and SQL. So don't underestimate the power of SQL. In fact, Spark SQL is the most widely used library right now. Spark also supports SQL because there are a lot of people who are coming from the RDBMS background, data warehousing background, ETL, business intelligence, all this. And all these people are comfortable around SQL. So Spark also supports SQL. You will be able to program using SQL in Spark. So what are the points we discussed? Spark runs 100 times faster than MapReduce. Ease of use, like you can choose any of these languages and start working with Spark. Generality. So this generality is a very important topic. Combine SQL, streaming, and complex analytics. What do you mean? So one of the challenges we have in the big data world is that if you look at all these modern day projects, any big data project, there will be multiple types of requirements. To give you an idea, I am currently working with a customer, and my customer is actually from Australia. So they are an e-commerce company. So my customer is into e-commerce. E-commerce means what? Like Amazon.com, something like that, right? Now, their problem is they want to do a lot of machine learning on the data. They also want to do something called deep learning. They also want to do SQL style of queries. They also want to do real-time analysis. So in the modern day, the problem we face is that there are multiple types of analysis. To give you an idea, let's take the example of a e-commerce company, right? So if you're talking about an e-commerce company, maybe one of the things they would like to do is they want to use machine learning to recommend new products to users. See, for example, if you're browsing Amazon, you always get these recommendations, right? What you want to buy. So this recommendation engines basically use machine learning. So let's say you are working for a typical e-commerce company. They would like to use machine learning to do recommendations and other kind of things. Second thing is that they want to do things like, for example, if you are searching for something in the website, right? They would like to analyze your text, so it is called natural language processing, or this is called NLP. What is NLP? For example, you are typing with somebody, chat window, right? They would like to analyze all these chats and then understand what is your mood and were you satisfied with the service, etc. So all the companies would like to do this. They also would like to produce batch reports using SQL and visualization. So all the companies would like to produce a lot of reports. The reporting is very important. So probably they would like to use, SQL as their tool. That is also another requirement. Now, they also would like to do real-time analysis of user data. Example will be by looking at what users are searching on website, the company can offer real-time deals. You see this, right? Sometimes when you log on to Amazon, you will see that there will be an offer which says, okay, 40% off. This will expire in 10 minutes. Why? Because Companies like Amazon, they analyze the data in real time and they give you offer. So the problem is these are all different types of analysis. Machine learning is different, NLP is different, SQL is different, real-time analysis is different. But the speciality is Spark can do all of these alone. So Spark is capable of doing any kind of analysis that you want. SQL, streaming, machine learning, deep learning, anything you want, Spark will be able to do. So that's another specialty. And last but not least, runs everywhere. So Spark is completely platform independent. You will be able to install Spark on any platform. For example, you can install it on top of Hadoop. You can install it on Linux. You can install it in the cloud. You can install it in Kubernetes and whatnot. So Spark is 100% platform independent. You will be able to install it wherever you want. So with all these details, Spark becomes the default standard for big data processing, right? And that is the reason in this webinar, we are talking about Apache Spark. Okay, so what did we discuss so far? So we discussed a couple of points. Let me summarize. First of all, what is big data? Right? So we know that big data is huge amount of data, probably structured and unstructured, so that you will not be able to process it using traditional solutions. I mean, think about it. When it comes to data analysis, what do you normally do in the traditional world? The first thing that people remember is RDBMS. Now, you cannot process big data using RDBMS. Why? There are a couple of reasons. First of all, RDBMS works only with structured data, like a row column format. Second reason is RDBMS platforms are also very, very costly. Say, for example, you may argue saying that if you want to process, say, 100 terabyte of data, you can actually use Oracle. And I totally agree. You will be able to do this with Oracle. But look at the licensing cost, support cost, all this for Oracle. It will be damn costly. So when you come to the world of big data, you are also looking for a cheaper solution. And that is our Hadoop. So then we discussed about something called Apache Hadoop. So what is Apache Hadoop? Apache Hadoop is the first solution for storing and analyzing big data or huge amount of data, right? And how Hadoop helps us to do this? So Hadoop can be installed in what we call a cluster. A cluster is nothing but group of machines, okay? And so if you create a Hadoop cluster, let's say with 100 machines or 500 machines, it can utilize all the hard disks, so your storage problem is solved. Hadoop also allows you to do something called parallel processing. So even processing can be faster with Hadoop. Okay. And then we discussed about something called Apache Spark. Okay. So Apache Spark is the latest and greatest big data processing engine. Again, this is also open source. It is from Apache. So Spark's specialities, first of all, it is 100 times faster than MapReduce. You can write Spark programs in Java, Scala, Python, R, and SQL. You can combine machine learning, SQL, real-time, any kind of analysis. and you can install Spark wherever you want. So all this makes Spark the default standard, right? Now you may be wondering, so let me see if I can show you this. You may be wondering, hey, can you give me some use cases for Apache Spark? So let me just see. Powered by Apache Spark. Yeah, I think here. So you can see that all these companies are actually using Spark. Some of them will be very familiar to you. For example, Alibaba, and there is something called Aluxio, and there is Amazon. So Amazon uses Spark, Alibaba uses Spark, Autodesk uses Spark, Beidou, it's one of the biggest, biggest taxi services, I guess. Beidou also uses Apache Spark. Let me just check here. Yeah. Then there is like, Databricks, there is eBay, there is Exabeam, Groupon, Hitachi, IBM, and then of course NASA for sure, Uyala, then lot of other companies, right? So this is just a partial list. So TripAdvisor, Yahoo. So this is just a partial list, but you can see all of them are using Apache Spark, right? So many of the big names in the industry actually uses Apache Spark for their big data analysis. And at Intellipaat, what we actually have is we have a course which is called the Big Data Masters Program, where we teach Hadoop and Spark together. So you will be first starting with an introduction to big data. So you will learn like what is big data in depth and all these things. And then you will learn about Hadoop and what is Hadoop architecture and so many other things. And then you will land in the Spark. So in the Spark classes, you will be learning end to end of Apache Spark. And also there will be a lot of lab sessions and hands-on sessions. Let me also talk about this. For example, what we normally do for the lab is that for every candidate, we give them something called the Intellipaat VM. So you will be able to install this virtual machine on your local PC to practice all the lab examples. So let me quickly open this and show you. So I'll just try to open this. Give me a minute. So every participant will be getting a copy of what we call this Intellipaat virtual machine. So this is a virtual machine which you can install on your PC, and then you can start it. And you will be able to install Hadoop, Spark, everything here, and be able to use it. And I can just try to log on to this. And this virtual machine is actually running Linux, okay? And here you can see that I can open the terminal. I can just type, for example, Spark shell. Okay, so I need to enable the remote connection. Let me do that. So let me just connect with this machine. Yeah, I just connected with this machine, and you will be able to install Spark like this, and you will be able to open Spark and see. So this is just to show you that how people will be able to do the lab part. So normally we provide this virtual machine so that people will be able to do the lab. So let me just show you this Spark which is installed on this VM. I think it will start in a minute. Don't worry. My VM is a little bit slow, so that is the reason it is taking time. Yeah, so now you can see it starts, and you will be able to see the Spark version. So we are using Spark version 2.3.0. So you can see very well in the virtual machine that there is Spark installed. Okay, so I would like to talk about one more thing. Spark was created in 2009. Okay, in 2009, in the University of Berkeley, there were a bunch of students who were doing research, and they created Spark as part of their research project. Okay, and these people, they created a company which is called Databricks. So Databricks is a company which is created by the founders of original Apache Spark. So today I would like to show you a demo of Apache Spark, and I think most of you might be also waiting for that. So I would like to take a simple case study and then show you a demo for Apache Spark. So what I have right now with me is, you can see welcome to Databricks and all. So this is what you call the Databricks Community Edition. Okay. So this company called Databricks, they offer a free lab in the cloud. So you can sign up with Databricks and they will allow you to use a completely free lab in the Amazon cloud. And I just signed up for the lab, and this is how the lab looks like. And the first thing that I'm going to do is I will go to this clusters menu. You can see it says no clusters. Let me create a cluster. I can click on this create cluster. And let's give it a name. I'll call it as demo cluster. And you can choose the Spark version. So I'm just going to pick up one of the Spark version. Let's say this one, and just say create cluster. So very easy, with a single click, you will be able to create a Spark cluster, and this is absolutely free. And in our course, we will be also using this environment for practice. We will be using the Intellipaat VM, but we will be also using this Databricks Community Cloud. Okay, so what is the case study for today? I don't know how many of you are aware of this, but there is a company called Yelp. Okay, so probably if you are in the US, then you already know what is Yelp. Yelp is not available in India, as per my knowledge. So Yelp is a company which allows you to rate and review local businesses. Yelp originally started as a company which helped people rate and review different restaurants. But in the modern day, you can go to Yelp and you will be able to review anything. For example, I can just search for plumbers in San Francisco. So I'm just searching for plumbers, and then you can see a lot of plumbers here. Let me show you. Yeah. So these are all different plumbers available in San Francisco, right? And you can just click on any one of them. You can see if I go to this particular service, let me try to go to this service. So this is called what? 24/7 router and plumbing, something like this. You can see their star rating, their reviews, and their license, highlights of the business, photos, services offered, all these things. So basically, Yelp allows you to find a local business and also rate it. Yelp also allows you to download their data set. Okay, so Yelp has all this data public. So whatever businesses are listed in Yelp, you will be able to download it as a file. And I have already downloaded a sample file, which is this. Let me open this file and then talk about it. Yeah, so let me close this. So this is basically the file which contains all the Yelp reviews, not all of them, but some of them. As you can see, this file, first of all, is a semi-structured file. It is not a Excel file or a CSV file. This file is in the JSON format. It's semi-structured data. So you can see that it will be having all key value pairs. For example, there is a key called business ID, and then you have the business ID. Then you have like full address, you have full address. Then you will have like hours on Tuesday, when they will close, when they will open, etc., etc. Then you will have, the city name, which is Phoenix, review count. Then you will have latitude, longitude, star rating, all these details, right? And this will have different type of business. Okay, so every business will be a different type. For example, this is a school. Rise and Savior Lutheran Church and School. This is a school actually, right? So if you go to this name, you can find it, right? So this is again Asian Grill. See, this is actually Chocolate Star Bakery. So our problem is we would like to analyze this data. So there are two problems here. First problem is this is in the JSON format, which is completely like not structured. The second problem is there are a lot of businesses in this. So how are we going to analyze this data? We are going to use Apache Spark. So let me go to this Spark page, and we were asking to create a cluster. Let me go here, demo cluster. Yeah, so the cluster is running. So we just created a sample Spark cluster. And what I have done is I have already uploaded the data to this cluster. So if you go here, you will be able to find it. Let me show you. So there is an option to import and export data. If I go here, I can show you where is the data. You can see tables and business.json. So you can see that this business.json file is already available in my Spark cluster. In fact, let me copy the name of it and let me open this file. Give me a minute. Yeah. And how do you analyze this data? So in order to analyze this, what we will be doing, we will be creating something called a notebook. So there is an option here, you can see, create a blank notebook. What is a notebook? A notebook is an interactive environment where you will be able to write code snippets, execute them, and see the output. So I can click on this create a blank notebook, and let's give it a name. Let's call it as Yelp analysis. And the programming language is Scala, say create. Okay. And let me attach this to the cluster. Confirm. Yes. So now this is what you call a notebook. So in order to read a JSON file, there is a very easy thing you can do in Spark. Okay, let me run this command. Yeah. So if you would like to read any JSON file into Spark, you can just say spark.read.json and just provide the location of the file. That's it. So you don't have to mention any schema, any column name. Nothing is required. Spark is going to analyze this JSON file. It will figure out the schema, and it will give you something called a data frame. Let's see that. So if I hit enter, so this command is running now, and Spark is trying to read our JSON file. Let's wait for that. And it seems Spark is trying to read. All right. So what is interesting now is Spark has read this file and identified all these column names. Can you see? So there is something called accept credit card, accept insurance, alcohol, ambience is casual, classy. All this is in the data, the attire, catters, and dietary restriction, good for dancing, hairstyle. All this it got from the JSON file. So basically what Spark has done, it took the JSON file, looked at all the keys in the JSON file, and created a table-like structure, which you call a data frame. So you may be wondering, what is this BIS you have created? This BIS is what you call a Spark SQL data frame. What is a data frame? A data frame is very similar to a table. It will have rows, it will have columns. Let's try to see that. So I can say display, then this BIS, run this. And watch. Here is your data frame. See? So this is how the data looks right now. See, there is one set of column here. Then there is business ID, that is another column. Then there is categories, another column. Then there is city, another column. Full address, hours, latitude, longitude, name, neighborhood, open, review count, star, state, type. So basically, this is what you call a data frame. It is equivalent to a table in Spark or Spark SQL. And we were able to create it right from the what you call JSON file. Okay, fine. What else? So once you create this data frame, I will be able to register this as a table. So this command, what it does, it registers my data frame as a table so that I can run SQL queries. So now I have got a table with the name BIS, and I will be able to analyze this Yelp data using SQL. Let's try that. So let us say you would like to know total how many business are there. I can just say spark.sql, select count one as business from the table. Let's run this. You can see that it is pretty fast, and the answer is 61,184. Very well. Let's try to look at all the businesses grouped by the state. So again, these are SQL queries. You're going to do a select state, count one as business, group by state. So let's look at state-wise how many businesses are there. You can see Arizona has the highest number, 25,230, and then the other states as well. Okay. Now let's try to look at all the businesses which are having 5-star. So you can say select name, stars, review count, city, state from the table where star equal to 5. Let's try to do that. You can very well see that. So once you create this data frame, you will be able to run any type of SQL query, right? And I have created a bunch of queries. Let's run this last one. Let's say you want to select name, stars, review count where city is Las Vegas, order by stars descending, review count descending, and say .show. Let's see what happens. So I would like to see in Las Vegas all the restaurants with the review count and the star. Not only this, your Databricks environment also allows you to visualize the data. So what I can do is, there is built-in visualization. So I can just try to do that. Let's try to do a display DF. Okay, sorry, display this, I think. Let's try to look at the original data. So this is the original data. And I can say that I would like to look at it as a bar chart, right? And I can have plot options, okay? So I can say the key is probably, I don't know, state, and value is star, apply, confirm. Let's try this. Yeah, so you can actually see state-wise, how many star ratings are there, like a bar chart. So the Databricks environment not only allows you to analyze the data, it also allows you to visualize the data. You can have any kind of visualization. For example, I can have a map. I don't think it will work in this case. Yeah, so let's try for a pie chart. Okay, you can see that we are able to get a pie chart. It can be bigger like this. See? So you can see each state and how many reviews are there, so on and so forth, right? So the Databricks environment not only allows you to run the analysis, but also visualize the same. Okay, and I will be able to share all this material if you want, the code and the data, so that you will be able to do that. But in our complete Spark course, we take lot of real-time data like this. We run analysis and we try to look at Spark in different ways, right? So as of now, probably this was a very small demo, but a very quick demo where I wanted to show you how quickly you will be able to look at data which is in semi-structured format and then analyze the same, right? So now let's do one thing. Let's pick up some questions from you. So I was not really answering any questions. So let us try to answer some of your questions now, right? There was one question from Anandu. Is Spark a component in Hadoop architecture? Not really. So when you look at the original Hadoop architecture, Spark is not a component, Anandu, but you can install Spark on top of Hadoop. Let me show you. So if you look at this picture, Anandu, right, you will get an idea. This picture. So this is the Apache Hadoop ecosystem. You can see there are a lot of components, and this is how Spark fits in the Hadoop ecosystem. So you can see for batch processing, there is Spark. For ML, there is Spark. SQL, there is Spark. And real time, there is Spark. So even though Spark is not part of your Hadoop architecture, you can install it on top of Hadoop. Guys, let me know your questions. Please type your questions in the chat window so I can answer them. Another question, can you please suggest the roadmap for learning Apache Spark for a total fresher? So Anandu, what we have here at Intellipaat, our syllabus is actually designed for people to learn Spark from scratch, because Like I said, we will be starting with an introduction to big data, introduction to Hadoop, then Spark architecture. We will even be teaching Scala programming language. So at Intellipaat, our syllabus is actually for anybody who would like to learn Spark from scratch. Anandu was saying, can you please show visualization again? Yes, I can do that. You had any questions, Anandu? Let me just show this. So this is the visualization. Okay. So here you have the option. I can say bar, and then you will be getting the bar chart. If I go to options, aggregation, I can take average and say apply. Give me a minute. Yeah, so now you can see the average star rating for each state. Okay, Arizona has 3.6, California has 3.3. So this is a bar chart where you can see the average star rating in that state for all the businesses, right? Is that what you wanted me to show, Anandu? Just to clarify. I hope so. Another question, can you share the material with us? Yes, my team will be sharing the material, Femi, don't worry. I will send it to my team and they will share it with you. As a starter, where do we begin this course? So like I said, our course always start with introduction to big data, right? So that is where you're supposed to start, and our course is designed to start with that, okay? What is the cost of the course? Just hold on, Femi. My team will answer that question. Don't worry. Another question, can this analysis be done outside Databricks? No. This can be perfectly done on any platform, Olu, right? I just thought I will show you Databricks because it is free and easily available. This analysis can be done on any Spark platform. Chandan says, this is Chandan. We created a cluster of 15 GB on Databricks. This 15 GB space will be working as RAM. Yeah, this will be RAM, Chandan. So Databricks by default give you a free cluster, and that will be a single machine with 15 GB RAM. So this is RAM. You will be also getting, I think, around 10 GB hard disk space to upload your files. Databricks environment we can find in Azure too. What is the difference between this comparing to the Azure Databricks? Not much difference. Okay, so here this is their free version, Peter. So Databricks is also available in Azure. That might be a paid version. This is what we call the community version. The paid version might have some more extra features. That's all. Can we integrate this with other reporting tools like Tableau? Absolutely. So in the community version of Databricks, they don't have integration with Tableau, but in the enterprise version, you can connect any BI reporting tool. Correct. What is the duration of your course? Smita, just hold on. We'll discuss that, okay? So there are a couple of people, Vasudev, Smita, asking for the duration. So my team will be joining right now. My colleagues will be joining right now, and they will be discussing about the duration and cost and other things. Let me know if you have any technical questions. I'll be more than happy to answer any technical questions. Let me know. Another question was, what are the okay, syllabus you are going to cover? So the syllabus will be, we can send the syllabus to you, Vasudev, okay? Whatever syllabus we are going to cover, we can send it to you, okay? Don't worry. Since we say, another question, Spark process data in memory, what does it mean actually? So Chandan, what it means is that the whole data set can be loaded in the RAM and then the processing can happen. In-memory processing basically means the entire data set can be loaded in the RAM of machines in the cluster, and you will be able to analyze that by keeping the data in the RAM. Now, why this is special is because if you look at the other frameworks like MapReduce, so people always compare Spark with MapReduce. MapReduce is the older execution engine. When you look at execution engines like MapReduce, they don't do in-memory processing. In MapReduce, during the processing of data, it can write intermediate output to the hard disk. So it will be very slow because there will be a lot of read and write from the hard disk. But in case of Spark, Spark is faster because of this in-memory processing that we have. What are the ML support in Spark? Can you talk about it briefly? Okay, more than 90% of big data machine learning workload is handled by Spark in the modern day. So Spark supports almost all the machine learning and deep learning algorithms. So I can just show you this. Let me just go here. Spark has a library which is called MLlib library, or it stands for machine learning library. If you go to this library, you can see what are supported by Spark. For example, you can do basic statistics. So there is correlation, there is hypothesis testing. Then you can do EDA, exploratory data analytics. You can do classification and regression. So Spark supports classification and regression. You can do logistic regression, binomial, decision tree, random forest, naive any of this. You can also do unsupervised learning. You can do k-means clustering. You can do collaborative filtering, algorithms like alternate least square. All this can be used with Spark. And if you're talking about deep learning, Spark supports all the latest deep learning libraries. You can use PyTorch, you can use TensorFlow, you can use Keras and whatnot, right? So all these are supported by Spark. Does Hadoop, Spark, etc. compatible with Windows? Not really. Hadoop, Spark, they are usually compatible with Linux platform. Okay. What notebooks can be used outside Databricks, Jupyter or Spider? You can use Jupyter notebooks, Olu, right? What is data lake? Is it different from HDFS or is it part of HDFS? No, so you can consider HDFS as an example of a data lake. A data lake is a place where you can store any type of data, right? And Hadoop HDFS can be taken as an example of a data lake, okay? So data lake is nothing but a common storage of any type of data. What is PySpark? PySpark is nothing but Spark only, where you are using Python as a language. So if you are programming in Spark using Python, it's called PySpark. What are the benefits of Spark over MapReduce? So I think Vasudev, you were paying attention when we discussed this point. When you just go to the Apache Spark website, I think we discussed these points. The first one will be speed, right? 100 times faster than MapReduce. Second is this ease of use, again comparing with MapReduce, and these two. Runs everywhere and generality. These are all advantages over MapReduce. Any other questions? Let me know. Well, I'm not in a hurry, but I'm just asking in case if you are having any technical questions. Non-technical questions, just hold on regarding the duration or course fee. We will answer them. Just hold on. Okay, I think we are good. Let me just pick up some more. If we have 10 million records in a table and we write query on this table as select column name, filter, how it will run parallelly if we have 10 machine of. So Chandan, this question requires a very detailed answer. I probably will not be able to give you the answer right now because you need to learn a lot of other things to understand the answer. But just understand that within Spark, there is something called drivers and executors and partitions. So you need to learn that first to understand the answer to this question, Chandan. Okay, so Spark uses a concept called partitioning, and then there is a concept called executors. So executors are JVMs which processes a part of your data, right? So probably, Chandan, we will discuss this later. I will make a note of your question, but you need to go through some more topics to answer this. Any advantage to use PySpark over something like Teradata or Vertica? The major advantage will be the cost factor. Since Spark is open source, the major advantage will be the cost factor. Your cost will be 10 times reduced if you are using Spark. Second advantage will be if you're talking about something like Teradata, mostly you're talking about structured data, row column format. Spark will be able to handle any type of data, which I think Teradata or Vertica cannot do. You can process images or videos or binary files or any kind of file format. Another question, Yelp data that we use was in table format, more like SQL. How can we say it is unstructured data? Now, the Yelp data is not unstructured data. I was not saying it was unstructured data. Yelp data is semi-structured data. It's not unstructured data. We were not processing unstructured data. It was semi-structured data only. Okay. What else? So I think probably I will hand over the discussion to my team. So my teammates are here and they can pick up more questions from you. So over to you, Charles, if you can take over and then answer some more questions from them. Charles, if you're there, then probably you can take this from me.
Charles, you will have to unmute your mic before you can speak.
My bad. Hi guys, hope you're doing good and hope the webinar was informative. So my name is Charles Christopher. So what I'll do is I'll take you through the course content, explain you the benefits, what's in it for you, why you should choose Intellipaat, and what's the duration, what's the schedule, everything in detail. So we are here on the Intellipaat homepage. So you just need to type the program name, big space data, big data, and you will find multiple results here. So click on the first one which says Big Data Hadoop Certification and Training. Well, this is Big Data Hadoop and Spark, which is a 60-hour instructor-led duration training program. So with the live instructor, it's going to take about 60 hours to completely become proficient with big data as a technology. Well, if you scroll down here, you will see the complete overview of the program. What will you learn in this Big Data Hadoop training? And who should take this training? What are the prerequisites? Why should you go for Big Data Hadoop training online? And these are the ideal topics that's going to be covered: Spark, Scala, Scoop, Big Hive, etc. So if you scroll down much further, here you'll see the complete course content. So Big Data Hadoop course content. So these are all the modules that are going to be covered from basic to advanced, step by step with the live instructor. So if you click on each and every module, you will find the detailed topic that's going to be covered. So you'll be literally learning from Hadoop installation and setup, and introduction to big data Hadoop. What is big data? What is where does Hadoop fit in? Everything from very basic to advanced, step by step. And if you notice, each and every module has hands-on exercise. Each and every module. So this is purely a practical learning platform, not any sort of boring lectures or presentations, because all our instructors are working professionals with 15 plus years of experience in IT, who works for the top MNCs, and you are directly learning from an industry expert. So this is purely going to be a practical learning platform. So if you scroll down, these are the list of modules that is going to be covered, and these are the separate 5 modules that will be covered in self-paced mode. And if you scroll down further, here is a very important thing: Big Data Hadoop course projects. Now, these are the real-time industry projects that you're going to have a hands-on exercises or experiences on. Now, this is very, very important, because no matter where you learn the technology, without having a hands-on, it's quite pointless and useless. So without having a hands-on experiences on projects, it's quite impossible for anybody to clear the technical round or even clear the interview for that instance. So we provide you the necessary lab for you to practice the projects and also learn the technology. And we provide lifetime technical support assistance whenever you're stuck or whenever you have any query. We are there to help you, guide you, and assist you. So each and everything is mentioned on the website itself, including the project and its detail, what sort of project that you'll be having hands-on exercises or experiences on. So these are the list of 9 to 10 projects, which is clearly mentioned on the website itself. And if you scroll down further, here you'll find Big Data Hadoop certification. Now, not everybody's objective is to appear in the exam and clear the certification exam, but there are for quite a few people who are also interested in this. Well, the course is also designed for you to clear Cloudera, Spark, and Hadoop certification developer exam, which is also known as CCA 175. Now, we have more than 92% of passing aggregate for this certification exam. The reason why we have such a high aggregate is we provide you a mock quiz on our website. If you score 60% in the mock quiz that we provide to you, that means you can easily clear the certification exam in just one attempt. So make sure to take our mock quiz before you appear in the certification exam, which means you can easily clear before you invest your money. So this is the IPM course completion certificate, which you'll be rewarded once you complete the course and exercises and assignments given by the instructor. This particular program is in collaboration with IBM. You'll be getting a course completion certificate issued by Intellipaat, acknowledged by IBM, once you complete the course as well as the exercises and assignments. Now, coming to the key features of the program. This is a 60-hour duration training program. Whether you take weekend batch or weekday batch, up to you. It's going to take 60 hours to complete the list of modules that I just showed you. All these 19 modules with the live instructor to complete, it's going to take about 60 hours of duration. 80 hours of self-paced content. So 60 hours of the same modules plus these 5 modules, everything put together, it's going to be 80 hours of self-paced videos. 120 hours of projects and exercises. So I showed you the list of projects that is going to be, that you're going to have hands-on exercises or experiences on. And I also showed you the exercises. So these are all the hands-on exercise, each and every module. So it's going to take about approximately 120 hours of your time to complete those. Flexible schedule. Now it is up to you whether you want to attend a weekday batch or weekend batch, or you want to switch from weekday to weekend or vice versa, or if you can attend both, no problem. So that's what flexible schedule means. Now we are the only company to provide you a lifetime access, not only to the content, but also with the live instructor-led training itself is for lifetime. So you can attend unlimited classes. You can retake the classes unlimited times. Nobody's going to stop you or question you. So attend as many batches for lifetime, no questions asked. Let's say, for an example, you started your batch, but after a couple of weeks, something came up with regards to your work or personal reasons, you could not continue. No problem. It took a month or two for you to again sort yourself out and you're available. Just drop an email to our support team, start retaking the classes again from the beginning. No questions asked. Lifetime support and access. So lifetime technical support assistance is given to you so that you can access any questions or any queries you might have without the instructor Monday to Friday when you're available. Drop an email to support team. They're there to help you, guide you, and assist you. And whether you attend the class or miss the class, live recorded videos of your own classroom is also going to be shared with you. Irrespective you attend the class or miss the class, live recorded videos are given to you. And the classes are interactive. Like you already have the experience of attending this webinar. Any questions you have, the instructor is going to answer to those by end of the session on the same day. Now, certification and job assistance. Well, certification I've explained to you. The course is designed for to clear CCA 175 exams, and we provide you certification preparation by giving you the mock quiz. Job assistance. Well, job assistance works in 3 steps. Step number 1 is we are going to rework on your resume. Step number 2 is we are going to prepare you for the interview with a list of mock question and answers. And the final step is we are going to provide you an access to our portal where we have tied up with 80 MNCs, and you get to market your resume. Companies like TCS, Cisco, IBM, Microsoft, Standard Chartered, Sony, MU Sigma, just to name a few. But once you start getting interview calls, how you perform in the interview or how you proceed further, that is totally left up to you. But for you to become industry ready, whatever is required, we take care of that responsibility 100% in making sure that you are learning the technology and becoming proficient with the technology in and out. Well, about the schedule. Well, these are the list of dates. So these are all the fresh batches that we have for Big Data Hadoop and Spark program. Now, weekday batch will be Monday to Thursday. So Tuesday to Friday, 7 a.m. Indian Standard Time is Monday in the US or in Northern America. So it's Monday to Thursday. A fresh batch is starting tonight for the US. The timings will be 8:30 p.m. to 10:30 p.m. Eastern Standard Time. Monday to Thursday, 4 days a week, 8:30 p.m. to 10:30 p.m. Eastern Standard Time. This is the weekday batch schedule. Weekend batch schedule is Saturday and Sunday, 9:30 a.m. to 12:30 p.m. 9:30 in the morning to 12:30 in the afternoon, Eastern Standard Time. 3 hours Saturdays, 3 hours on Sundays. So you can either choose a weekday batch Monday to Friday, 8:30 p.m. to 10:30 p.m. Eastern Standard Time, or you can either choose Saturday and Sunday, 9:30 in the morning to 12:30 afternoon batch, whichever is feasible for you. Now, about the pricing. So self-paced is a pre-recorded video, while online is with live instructor-led training. So online, you get 10% discount, but reach out to me for 30% discount. So if you're paying in INR, it's going to be additional 18% GST, or you can directly pay by US dollars as per the website price. So it's going to be, again, the discounted price. Instead of 10%, you get 30% if you reach out directly to me. So instead of $399, you get 30% if you reach out to me. Now, this would be the number or the email to reach out to me directly. You can WhatsApp me directly on +1 202 221 4214 or +91 861 8484 729, or drop me an email to charles.christopher@intellipaat.com. So kindly take a print screen or make a note of it. I'm here to answer to any queries you might have, and also suggest you why explain you everything in detail about the benefits of choosing this particular program with Intellipaat. Well, I want to also show you one more program. Well, let's start from the beginning. So let's say we are on the home page. So let's type big space data, and here are the list of programs. So Big Data Architect Master Program. Well, This program again is in collaboration with IBM. So this is a combination of 13 courses. Now, towards your right-hand side are the list of programs. This has Big Data, Hadoop and Spark, which I just took you through. In addition to that, this also has Apache Spark and Scala, Splunk Developer and Admin, Python for data science, PySpark, MongoDB, AWS Big Data. So these are the 7 programs with the live instructor. Hadoop testing, Apache Storm, Apache Kafka, Apache Cassandra, Java, and Linux. These are the self-paced. In total, this is a combination of 13 programs. Well, the benefits are literally the same. You can attend as many batches as you want. You can retake as many classes as you want. Nobody's going to stop you or question you. Whether you attend the class or miss the class, live recorded videos are in which was given to you. Now, if you scroll down here, you'll see the complete course curriculum. Whichever says live course, these are with the live instructor-led training program. Whichever says self-paced, these are the pre-recorded videos. Now, you can click on any of the courses. Again, you will see the complete course program from the very basic to advanced step-by-step, along with hands-on exercises. Well, my recommendation is always to go with this program, mainly if you're looking for a job change. Let's say, for an example, you have 5 years of experience in IT and you want to upgrade your skill set. You're working as a Java developer, say for an example. Well, if you're looking for a job change, that means you're looking for a better career with a better paycheck end of the day. So when you have 5 years of experience, any company would prefer hiring an architect who is well versed with multiple tools within the big data family itself. Not only just Big Data, Hadoop, and Spark, but also PySpark or even Python for that instance. Let's say, for an example, within a year of experience, you are promoted as a team lead or a program manager. You'll have to handle a complete project. Well, even though you're not literally working in each and every department, you need to actually understand what each and every department is actually doing so that you can report that to your higher authorities. Why is there a delay in the project? What's actually happening with the Python team? So for that, you need to understand the complete infrastructure itself. So that is the reason I would definitely suggest to go with this particular program. And the benefits are literally the same. Whether you go for 1 course or 100 course, doesn't matter. It's a lifetime access, lifetime technical support assistance. Everything is clearly mentioned on the website. So I'm not trying to be fancy over the phone or through this webinar, but it's literally mentioned on the website. One-on-one doubt resolution, attend as many batches for lifetime, flexible schedule, and so on. And the same thing even with regards to pricing. Instead of 10% for this program, I can extend you a flat 40% discount. Well, that Big Data Hadoop Jest program was 30% discount, but if you go with Architect program, you get flat 40% discount if you reach out directly to me. So for any further queries, you can always reach out to me on the same WhatsApp number, +1 202 221 4214, or +91 861 8484 729, or drop me an email at charles.christopher@intellipaat.com. So take a print screen or make a note. Even if you have any queries, if you want to discuss in detail, I'm here to help you, guide you, and assist you. I'm a career counselor and a course advisor. I've been doing this job for almost 12 years. So I know in and out about the technology. Why should you go with this technology and how is it beneficial for you? And if not this, what else you should go for? I'll be the best advisor that you can meet. So even if it's just to discuss, drop me an email or drop me a WhatsApp message. I'm here to help you. So hope I've given all the details about the program, the benefits that Intellipaat has to offer. So one last thing I also want to show you again with regards to the certification. So that particular program was designed for you to clear just Big Data Hadoop certification. Well, this is a combination of 13 courses in total. Well, this is designed for you to clear all these exams. Well, maybe not all of you are interested to clear all these examinations, but maybe you're interested only to take Splunk admin certification exam. So again, the same procedure. Take a mock quiz, score 60% in the mock quiz that we provide to you for Splunk. And if you score 60%, that means then you are ready to go invest your money for certification exam. You can easily clear the exam in just 1 attempt. And again, you'll be getting 2 certificates, one from IBM, course completion certificate, and one from Intellipaat. So that's it. Rest everything are literally the same in terms of the benefits, job assistance, support, lab access, lifetime free upgrade. Now, let me also explain about lifetime free upgrade. So these are all the latest content available in the market so far, but the technology is evolving as we speak. So tomorrow, for instance, let's say Python comes with Python Plus. Like there was C, then came C++. Tomorrow, if Python comes with Python Plus, with addition to that, if they release about, let's say, 5 additional tools, you definitely have to learn that also. When you're already in technology, you can't just stick to the old one. You'll have to keep upgrading yourself too. But the best part is you need not pay any additional money to learn elsewhere or even with us. It's a lifetime free upgrade. So we upgrade the content automatically. So whenever there is a latest version in the market, we also upgrade the content. So you get to learn the latest version for free of cost, even after 2 years, because it is a lifetime access that Intellipaat provides. So all these 13 programs, whichever comes with any upgraded versions in the market, we also upgrade the content so you get to learn the latest version for free. And one last thing about the pricing, instead of 10%, you get 40% discount for this program, plus self-paced is given to you for free of cost. So go for online. Instead of 10%, I can extend you 40% discount and you get self-paced for free. So please reach out to me on this number, directly WhatsApp me better, or drop me an email to charles.christopher@intellipaat.com. Thank you so much for your time and have a great day ahead.